Imagine trying to predict the behavior of a single complex molecule. A modern computer could take years, but nature performs the same calculation every trillionth of a second because nature itself runs on quantum mechanics. And now, for the first time, scientists are designing computers that combine classical logic with quantum physics to solve problems the universe already understands. Recently, IBM introduced a bold blueprint called Quantum-Centric Supercomputing, a new architecture that merges quantum computers and classical supercomputers into a single coordinated system. And this may define the future of computing itself. To understand why this matters, we need to start with the basics. A computer fundamentally solves problems by processing information through logic operations. Traditional computers use bits which can hold either 0 or 1. These bits move through logic gates like AND, or NOT, allowing computers to perform calculations ranging from weather forecasting to financial modeling. But some problems grow exponentially complex. For example, simulating a system with just 50 quantum particles require representing over a quadrillion possible states. For classical missions, this becomes practically impossible. Quantum computers approach this differently. Instead of bits, they use qubits. A qubit can exist as 0, 1, or both simultaneously. The state of one instantly affects another. And through quantum interference, certain solutions becomes amplified while incorrect ones cancel out. In theory, this allows quantum computers to explore vast solution spaces far more efficiently than classical systems. We have already explored all these theories with practicality in our quantum playlist. Please subscribe now and research the channel once. Today's quantum computers are still in what scientists call the NISQ era, the noisy intermediate scale quantum era. Quantum easily lose information due to noise, environmental interference, and hardware limitations. And that is why quantum computers alone cannot yet replace classical machines. Instead, now they must work together. This is where the new architecture comes in. In current approach, quantum and classical systems typically operate on separate platforms. Researchers must manually move data between them, manage different job queues, and coordinate scheduling across different environments. IBM proposes a unified ecosystem integrating quantum processing units, classical superprocessors, and AI GPUs that are managed by a single orchestrator. It treats QPU as just another resource, much like adding a GPU to a server thought. In this system, classical computers handle data processing and algorithm control. Quantum processors handle quantum simulations and optimization problems. For example, imagine designing a new medicine. A classical computer first models a molecular structure, then the quantum processor simulates electron interactions, something extremely difficult for classical physics. The classical system analyzes the results, adjusts the parameters, and sends the problem back to the quantum processors. This loop repeats until the optimal molecule emerges. This approach could revolutionize fields such as drug discovery, battery chemistry, climate modeling, advanced materials, logistic optimization. If scaled successfully, quantum-centric supercomputers could unlock carbon-neutral materials, ultra-efficient batteries, new superconductors, and breakthroughs in medical chemistry. Some simulations could run millions of times faster than today. However, several major challenges remain. Quantum processors must operate at temperatures close to absolute zero, requiring complex cryogenic systems. Quantum noise still causes frequent errors, and achieving large-scale quantum advantage may require millions of stable qubits far beyond today's hardware. Building such data centers will also be extremely expensive, but the innovation frontier is enormous. Researchers are now working on fault-tolerant quantum computers, advanced error correction codes, quantum networking between processors, and new programming language designed specifically for hybrid systems. In the future, entire quantum cloud infrastructures may operate alongside quantum AI supercomputers. In other words, quantum computers may not replace classical machines, they will complete them. Because in the end, technology is not just about building faster machines, it's about building smarter ways to understand our universe. And if our innovations truly help humanity move forward, then they should also help us sustain. Don't forget your formalities to our channel. Nandri, vanakkam.